So this is the problem that we were looking at in the last class, and we answered the first part. What is the distance d between the origin and particle 2 if the net electrostatic force on particle 1 due to the other particles is 0? That's the one that we did in the last class. And then the second part of the question asks if particles 3 and 4 were moved closer to the x-axis but maintain their symmetry about the x-axis, would the required value of d be greater than, less than, or the same as in part A? That was the next question, the next part of that question, right? So we were looking at the net force on the particle 1, and we set it equal to 0, if you guys remember, right? And that's how we found the big D. And then when we were doing that, we had to find the distance from 1 to 3, right? That distance, where you can see my cursor, and we had to find that distance. Now, if you bring it closer, the angle theta is going to be smaller, right? And then cosine 20, like right now it is cosine 30 or sine 30, depending on what you are looking at. And in order to find the hypotenuse, I believe we used the cosine theta, because the adjacent side, the little d, is given to us as 2 centimeters. So we know that. And then by using the right triangle theorem, we found the hypotenuse. Now, when the angle is becoming smaller, the distance changes. So you are going to look at that and decide what happens to big D when we bring the 3 and 4 closer. So I'm not going to spend too much time on that. I want to discuss the next question, problem number 23. Now let's start this. Number 23. Please draw a diagram and then write down the important information. We have the x and y axis are marked in the picture here. This is where Q1 is, and that's where Q2 is. And each of them have a charge 3.2 times 10 to the negative 19. Remember, we discussed in the last class, that the charge is quantized, right? So this is about 2 times the charge of an electron, but it is made positive. And the d distance, the little d, is given to us as 17 centimeters from the origin. Particle 3 of charge Q3, 6.4 times 10 to the negative 19 Coulomb, is moved gradually along the x-axis from x equals 0 to 5 meters. Now please note that earlier we had 17 centimeters and here we have meters. So note that, SI unit for distance is meters. And then the question, at what value of x will the magnitude of the electrostatic force on the third particle from the other two particles be minimum, that's part A, and part B, maximum? And then what are the minimum and maximum magnitudes? So I hope that you have all the numbers. Then I will remove this and start working on the paper. Hi, Noah.
Hello.
Hi, we are doing problem number 23.
Okay, thank you.
Okay. And if you are you working on your computer? Yeah, if so, can you take a screenshot?
I'm sorry, what did you say?
Can you take a screenshot of problem number 23?
Oh, okay. Got it.
All right, so I'm going to remove this and then I'm going to draw it on my paper. So, like we discussed in the last class, I think you should all see the symmetricity of this problem, right? So here you have x-axis and then y-axis, Q1 over here, and then Q2 over there, and then here's where Q3 is. And then the charge of Q1, Q2, they are equal, and the value is positive 3.2 times 10 to the negative 19. And the value of Q3 is also positive 6.4 times 10 to the negative 19. Coulomb. Now, as the problem says, the charge Q3 is free to move between 0 and 5. And the first part of the question is asking where would the minimum point be? And the range is given between 0 to 5. And then the other part of the question asks us where would the maximum be? Now, as a calculus-based physics class, you should have some idea about this. And if you do have some idea, send the idea directly to me on the text box. So understand that they are all positive charges. And this is the 0 point. And this can go from 0 to 5 meters. And I don't know where exactly the location is right now, but it can go from 0 to 5. X can change from 0 to 5. X can go from 0 to 5 meters. That's what's given to us. Okay, I have some on messages on the text. Let me check. I don't really see the correct answer, but what do you guys think about like the minimum position? Can someone speak up and explain it to me?
Well, at 0, the Q1 and Q2 would balance each other out and the magnitude would be 0.
Uh-huh. Yeah, that's right. So we can actually change the charge from 0 to 5, right? And here, when we place the charge right at 0 point, what will happen? Q1 and Q3. So let me actually draw that point. This is where we are now, the 0 point. And then I place the Q3 over here. And then Q1 is up here, Q2 is down here. And they are all positive charges. This is a positive, that's a positive, and this is a positive as well. Right? So because of Q2, Q3 will experience a force. I'm going to draw this as F32. And there you will have F31. Why did I draw the arrows the way I did? Because they are repelling. They're repelling each other, yes? And what can you guys say about this F31 and F32? Are they equal or are they different?
Equal.
They are equal because of the symmetricity. They are d distance away and the magnitudes of the forces are the same. So the minimum point happens right at 0. So if I find F31, so let me actually draw the line here so that you can see where the charges are. I mean, the picture doesn't really do the justice for the distance, but you guys know what I'm talking about. So if you find F31, this will be K, Q3, Q1 over D square. And if you find F32, that would be K, Q3, Q2 again over D square. Yes, but Q1 and Q2, they are equal. Right, guys? I mean, we say that here. I mean, I have it in lowercase, but why don't I make it bigger, like uppercase? So there you go. So we are consistent with the symboling. So since Q1 and Q2 equal, you can say F31 magnitude equals to F32 magnitude. So if you draw the force diagram here, like, you know, the free body diagram, this is what it looks like. Clearly, the net y component of the force equals to 0, and there's no net x component there. Right? So F net in this case is 0. F net at x equals to 0 equals to 0. There is no net force at point 0. That's easy. So this happened because of the symmetricity. If we had a different distance between the point O, I mean the origin to Q1 and the origin to Q2, that would have been a different case. But here we look at the symmetricity. They are equal and opposite. Therefore, they cancel out, and that's good. And on the chat, I now have a correct answer for the second part. Second part asks us to find the maximum. Right? So how do we find the maximum? We take the derivative and set it equal to 0. Optimizing in calculus. So that's basically what we need to do. So that can be a little tricky. So if you remember your calculus, that's great. Either way, let's find. I mean, I know Bree is a math major, right? Okay, perfect. So we have help. All right. So here we go. I am going to draw a general diagram placing the Q3 on the x-axis, x distance away. So here we go. It's x distance away. And this is my Q2. This is my Q1. This is my origin. I mean, I like to have uppercase Qs. I think it's easier. And there's my Q3. Now let's connect these charges. We have 3 of them. So we expect always n-1 type number of forces. And then Q2 is a positive charge, Q1 is a positive charge, and Q3 also is a positive charge. Now I draw my Q3 and Q2. I look at the Q3 and Q2 and I mark my force as F3, 2. Along the line, away. Along the line, away, because those are repulsive forces. And then Q1 and Q3, again, along the line, away. So you have F3, 1. Now we are done. Basically, we have F3, 2 and F3, 1, but we don't know the distances. The distance between Q2 and Q3 and the distance between Q1 and Q3, we don't know. The distance that the two charges are separated from the origin, we already know them as D. Now this is a place where we can use the Pythagorean theorem and we can find the hypotenuse. Right, guys? And the hypotenuse will be square root D square plus X square. And then we need this angle theta. The angle theta that also is needed. And it is the same angle theta over here and theta over there in the diagram. When we take the components, we may need cosine and sine. But again, due to the symmetricity, what can you say about the net y component on Q3?
It'll always be 0.
There'll always be 0, right? Because F32 and F31 are equal in magnitude. F31 and F32, they are equal in magnitude because due to the symmetricity. They are equal in magnitude. So when you take the y component, guys, sum of Fy, that would be, I can write it in case if there's someone who wants to know this. So that would be F31 sine theta minus F32 sine theta. Since F31 and F32 are equal, sum of Fy goes away. So the net y component is 0. Now the next thing is to find the net x component. Now the x component, finding x component is kind of tricky. Sum of fx is going to be F32 cosine theta plus, fourth quadrant cosine is positive, F31 cosine theta. The free body diagram, if someone wants to draw that like separately, here's how it would look like. F31 and F32, and there you have the theta and the theta. You can see that F32 is in the first quadrant, F31 is in the second quadrant. Now since F31 and F32 are equal, I can get them together. Again, I am writing this so that people won't get confused. F31 and F32. So I can write sum of Fx equals to 2 times F31 cosine theta. Now let me substitute to F31 cosine theta. Actually, I am going to write it over here. F31 equals to K Q3 Q1 over R square, where R is the distance that we found as D square plus x square. So my F31 becomes K, Q3, Q1. Those are all constants. I'm not too worried about them. And then here I have d square plus x square. When you take the square of the square root goes away. Since I am using the free Zoom, this will end in 10 minutes. So please log back, okay? Now I am going to find cosine theta also, same place here. Now the cosine theta is adjacent over hypotenuse. And that would be this. And if you are wondering about from where I got that, please have a look at this triangle. And the triangle has the theta over here. This is the adjacent and this is the hypotenuse. And if you like me to draw it over here, I can do that. So this is the setup. This is our Q3. And the distance from the origin to the Q3 is x. And this is where our Q1 was. And we found this distance to be square root d square plus x square. And this is the angle theta. And using SOHCAHTOA, we can find cosine as the adjacent over hypotenuse. So this is our cosine theta. So this is important and that is important, and I'm going to write them together in my equation over here. So that will give me K, Q3, Q1 over d square plus x square times x over square root d square plus x square. So my net Fx, my net force becomes 2 times K Q3, Q1, they are all constants. And in here I have x and d square plus x square to the power 3 over 2. Now as a student suggested, in order to find the maximum, I'm going to take the derivative of this and set it equal to 0. So in order to make it less, it is not going to be less complicated or anything. It just does look little better when I remove the summation and then say F net X instead. So 2K, Q3, Q1, and then I write it over here. So in order to find the X that corresponds to the maximum force, I am going to take dF net X by dx and then set it equal to 0 to find the X value for max force. So this is what U over V type of a thing, right? Ratio. Remember the derivative of a ratio? U divide by V type. I think it becomes V du by dx minus U dV by dx over V square. I mean, K, Q3, and Q1, they all have values, but it doesn't really matter. They go away when you are setting it equal to 0. What is the product rule again? Not the product rule, the derivative u over v dx. Am I right? Guys? I forgot. I don't know. I mean, I always forget which one comes first.
Yeah, it's that one.
Yeah, okay, good. So v du by dx minus u dv by dx over v square. So you can just take x as our u and d square plus x square to the power 3 over 2 as our v. Now, don't forget, inside also there's a function. Not just don't use the power rule. Inside also you have an x square term, so you will have to take the derivative of that also when you are taking the derivative of dv by dx. I mean, the derivative of v. That's what I have. What do you guys have? Do you have something different?
I got the same thing as you.
All right, perfect. And then set it equal to 0 and find a value for x. And also remember that our allowed region for x is 0 to 5 meters. You can always, you can see that there are x square terms inside, and that results you giving a negative and a positive value when you are taking the square root. But allowed value is, I mean, the allowed range is from 0 to 5. So you will pick the value that lies in between 0 and 5. I mean, I can try to simplify this a little bit. I can pull out a d square plus x square to the power half. And that will give me d square plus x square inside. And the 2 and the 2 cancels out, and there you have minus 3x square. D square plus x square minus 3x square, and this, and then this is equal to 0. What do you guys get? We have less than a minute to end this and then come back again. And the value of D is given to us as 2 centimeters, I believe.